Greetings, fellow mathematicians. This is another really good trigonometric substitution problem because it tends to appear on a lot of Calculus 2 tests and exams. So let's go through it. Now, first step is to always determine your trig substitution. And if you take a look at the square root expression, we have it as x squared minus a number, and that fits the form of a secant substitution. Since the number 4 is 2 squared, we're going to be using a as 2. So let's make our trig substitution as 2 secant theta. All right, calculate your differential dx. That's straightforward. The derivative of secant is secant times tangent. And there we go. Now, a tip that I want to give you, so that way you can be successful in your Calculus 2 course, occurs from here. Let's say you plug everything in, and the resulting trig integral that you get seems very complicated. That might be because you have a wrong derivative, and you have some incorrect factors there, which aren't allowing terms to cancel out and give you a simpler trig integral. So definitely check your derivatives here. And again, make sure you're comfortable. The derivative of secant is secant times tangent. That'll make all the difference here and give you a very straightforward trig integral, which we'll see momentarily. All right, let's go to the square root, and let's go ahead and cancel it using the trig substitution. So here it's the square root of x squared minus 4. And we're going to substitute x as 2 times secant theta. So square both the 2 and secant theta, you'll get 4 secant squared theta minus 4. Inside the square root, you can factor out from both terms a common factor of 4. We'll write that as the square root of 4 times now secant squared theta minus 1. It's another standard step. Again, if you don't know the standard steps, I have a video linked down in the description where we go through that in detail. And the key step here is making use of a Pythagorean identity. Make sure you know all three of them. The basic one, 1 plus tangent squared equals secant squared, we're going to subtract the 1 to the other side. And we're going to use secant squared theta minus 1. That equals tangent squared. So if we replace the part in parentheses here with tangent squared theta, that'll get the square root to cancel. If we put this all together, we have the square root of 4 times tangent squared. And now we can take the square root of each factor, and it looks like this will simplify to 2 times tangent of theta. Now let's go ahead and plug this all in. And again, don't forget to replace this x in the denominator with your substitution as well. So let's take our time with that. All right, and we're going to replace x with 2 secant theta. So x squared in the denominator, that should become 4 times secant squared theta. All right, we just simplified the square root, and we found that that simplified to 2 times tangent of theta. So we'll plug that in here. All right, and that numerator is 1. And again, don't forget to convert your differential dx, which is another common thing many Calc 2 students forget or overlook. So we have dx correctly here as 2 times secant theta times tangent theta d theta. All right, and this should simplify considerably. You can cancel out a common factor of 2. You can cancel out a common factor of tangent. And you can go a little bit further. You can cancel out a common factor of secant. And while this seems really nice, we seem to get maybe a peculiar trig integral. We have a factor of 1 over 4, but we're left with 1 divided by secant theta. And how do we integrate that? This doesn't seem to fit either of your basic antiderivatives of trig functions or any of the basic 2 types of trig integrals. So one of the best tips or techniques I can give is to take your trigonometric expression and rewrite everything in terms of sines and cosines. And here, we're just going to recognize secant, that's 1 over cosine theta. So equivalently, 1 over secant theta, just flip that, that's going to come out to just cosine of theta. So we get the integral here of 1 over 4 cosine theta d theta, and that's really simple to integrate, which is what makes this, again, a good test or exam question in a Calculus 2 course, because this step right here actually gives you a simple trig integral. And again, rewrite in terms of sines and cosines, you'll probably be able to be successful going through that. So here, your basic antiderivative of cosine, that's just sine. We have a factor of 1 over 4 times now sine of theta plus c. And our last standard step is to convert your trig function of theta back in terms of x using the conversion triangle. And that's the tricky part here, which we're going to go through. If you need more detail, take a look at the video I have linked down in the description where we go through all 3 of the substitutions and creating the corresponding conversion triangles to that. All right, so let's go to our substitution, which is x equals 2 times secant of theta. All right, let's first solve for the trig function. That's easy to do. We can divide by 2. I'm going to flip the sides and write this as secant of theta equals x divided by 2. Now there's ways to memorize how the combinations of side lengths works for the other 3 trig functions, secant, cosecant, and cotangent, but I don't know them. I always think and tell my students to think in terms of basic sine, cosine, and tangent. That should get you through everything you need in the calculus sequence. So here, let's go ahead and recognize secant as 1 over cosine, and we're going to flip both sides. So this will be equivalent to saying cosine of theta equals now 2 over x. And that, using basic SOHCAHTOA, will give us our conversion triangle. We're going to think of cosine of an angle as the adjacent side and then divided by the hypotenuse. And if we go ahead and create it, relative to our angle theta, cosine of theta, the adjacent side, that's going to be of length 2. And now it's the hypotenuse that is of length x. All right, we just need the third side, which you can work out using the Pythagorean theorem. And if you know the shortcut, it's always going to come out to be the radical expression from your original integral. All right, now what we want to replace and convert is sine of theta, and we can read that off directly here from the conversion triangle. So we just take a look at sine of theta and think in terms of basic SOHCAHTOA. Sine of an angle, that's going to be the opposite side divided by the hypotenuse. And if we just plug in the side lengths here, sine of the angle theta, opposite is going to be the square root expression, the square root of x squared minus 4. And the hypotenuse, that's of length x. And we are done. We just need to plug that back in here. Don't forget about the factor of 1 over 4. And we get our antiderivative, 1 over 4, times, now in terms of x, the square root of x squared minus 4 divided by x plus c. And there we go. This one was, again, very straightforward, but the typical place students either get tripped up or make mistakes. One, getting the incorrect derivative here, and that could give you a very complicated trig integral since some factors wouldn't cancel. And the other tricky part is just rewriting here 1 over secant in terms of sines and cosines. And that made all the difference because integrating just cosine of theta, that is really simple. Just sine of theta for that antiderivative. All right, all these, again, are standard Calc 2 problems. Hope you learned a lot from this one. If you did, support the channel, like and subscribe.